Good evening, everyone. Thank you for coming here today and spending your summer evening inside with us. Um, Today, I'm going to talk about on-device AI, which is Gemini Nano. So before I actually start with what it is, let's see what we are going to cover today in short. So we'll be talking about the introduction, which explains what it is and how it is different from the regular cloud LLMs. We'll talk about AI Core, which is the actual engine behind Gemini Nano. We'll also talk about the APIs that are used. These APIs are the ones that make us enable us to use Nano. I also have a small demo to show you. This will showcase how Nano is being used in the app, and also, of course, some of the limitations that Nano has. So we all know Gemini, right? I'm sure everyone knows what Gemini is. Uh, Gemini has two major models that Gemini has is our Ultra and Pro, right? Gemini Nano is a distilled version of these two models, and it lives directly inside your Android device, right? It is accelerated by the phone's AI chip. The chips are installed already on your device itself, and it is also managed by the OS. And the best thing about this on-device AI is that it is completely offline. It has no requirement for the network connection. If you look at the flow that I've added here, you'll see that the app tries to talk to the AI core. If they have any requirement to talk to the Nano, it first goes to the AI core, and the AI core talks to the device's hardware. Device's hardware is the actual chip that does all the difficult calculations things, and then the response is generated, which goes back to the app. If you notice, there is literally no connection to the network here. Everything is done on device locally. Okay, so let's see how was the evolution for Nano, right? So for the last few years, the team has been working on developing Nano, and if you see, it has evolved quite a bit. Initially, it was only text. It only supported texts, and it was also experimental. But later on, they added AI Core to it. AI Core is the actual engine that helps the Nano model to work. And then there was multimodal support, and after that came the Nano 4. Nano 4 is just a preview version right now. It was just launched this year. And the best thing about Nano is that it uses Gemma 4. If you have read about Gemma 4, the best thing about Gemma 4 is that it helps all the E2B and 4.2B variants. They are supported on the device, and you can just install the model and literally have the AI installed on your phone. And also, they are again faster and use less battery. So you might wonder, why do we even need an offline model installed on your device, right? There's actually no need for it because the cloud LLMs are already powerful enough to solve all our problems, right? But not really. One of the biggest challenges with cloud LLMs is privacy. It is a known fact that if you lose any data through cloud LLM, you might actually lose a lot of sensitive information, which we would like to avoid, right? So because the data does not leave the device at all, it provides full privacy. Nano provides full privacy to us. Also, because it is on device completely, it has very less latency. It literally responds in like milliseconds, which Cloud LM can never do. Again, because it is offline, because it does not require any network connection, it is completely offline. You can use it on flight mode. You can use it on subways, hospitals, literally anywhere. And also, there is no cost aligned to it because, again, we don't need network. The tokens don't go out of your device, so that's why it is cost efficient. We all struggle to the problem of token billing, and this is one of the reasons why Nano really helps out. So, like I said, AI Core is the actual core engine behind helping us use Nano, right? Now, what exactly is AI Core? So it is a system service that hosts the Gemini Nano. Now, what does it mean that it hosts? It actually takes care of the entire, it behaves like a manager. It behaves like a manager for the Nano. It takes care of all the heavy lifting. It'll download the model when it wants. It'll take care of it ensures that the AI is always updated. It'll make sure of everything. Even when we request for anything, it first goes to AI core, and then it is taken care of and passed on to the model, and then to the chip. So AI core is the one that takes care of the whole process. A few things to note about AI core is that there could be multiple apps using requesting for Nano's access, but there'll be only one AI core within a device. Even because there is just one AI core, it takes care of isolating. It takes care of isolating the app's content and also sandboxes it, providing again a privacy layer within the AI core itself, so that there is no data transmitted within the apps also. Like I had earlier mentioned, that AI core also takes care of connecting to the chips. So all the tensor TPU and also NPUs, all the chips that we already have on the device, which actually perform the mathematical operations, these are also communicating to the AI core directly. The AI core actually decides where does the operation execute. So here's a small diagram. It's a very high-level architecture of how this works. The things that I just explained, it's exactly that that your app is going to talk to the AI core. The AI core consists of the Nano within itself, and it also takes care of all the safety features. So when I say AI core talks to Gemini Nano, consists of Gemini Nano, it actually takes care of all the execution part. So, but there is also something called LoRa. I mean, I don't know if they call it LoRa, but it is LoRa, which is low rank or adaptation. What it actually means is that if you have any specific requirement which has to be executed on top of Nano, you can have your own specialized plugins and create those specialized plugins, train them according to the data that you need on your project, and then apply it as a plugin on top of Gemini Nano. And then AI Core will give you a customized response based on the plugin that you provided and also Gemini Nano. After all of this is done, it again takes care of the safety feature. Like you see, the safety feature is after the Nano. So what happens is AI Core will take care of make sure that your data is isolated from all the apps. It will make sure that every input and output is already provides its own privacy and goes to the chip. The chip does all the operations, and then it comes back to AI Core. Now the AI Core, again, when it comes back, it again looks for security issues, if any, and then responds back to the app. Okay, now that we have seen what is AI Core and how efficient it is, and that is the main engine that we actually need, but the way to access AI Core is through the MLKit GenAI APIs, right? These are the APIs that MLKit has provided for us. All we have to do is just call these APIs and make sure that all the available facilities from the AI Core is available to us. If you see, summarization, proofreading, rewriting, image description, and speech recognition, all these APIs were already provided by Nano, and these are the APIs that MLKit has already provided to us. We can just literally use them and start creating your own projects, right? But lately, after I think in the beta version of GenAI API, they have created this prompt API. Now, this prompt API helps us write our prompt texts and communicate to the Nano directly without explicitly asking for certain things, right? We'll look into it more detail when I show you the demo. All right. So now let's see how are we going to make use of this. So when I said the APIs, they directly help us communicate with Nano, with AI Core as well. We have to first make sure that the model is available on the device. So before even you actually perform any operations on Nano, it is important that you check it. Otherwise, your app is just going to crash. By calling generation.getClient, this is the API that will just give you the model directly, straight away. Now, generation is a class that is present in the MLKit itself. Once you add the dependency, you should directly get it. And After you get the model, all you have to do is check the status of it. While checking the status, all you'll get is 4 different statuses. It'll be available, downloadable, downloading, and unavailable, right? Now, if you notice this, that if a device supports Nano, it'll let you download the model. Okay, it'll say that it is downloadable, and it'll let you download the model, and then you can start using it. It'll come into the available phase, and that will start using it. So there are very few devices out there that help Nano right now, that support Nano. If you look for anything before Pixel 8, nothing supports Nano. Nano has been supported from 8 Pro. So right now it is just available starting from 8 series, 9, and 10. And also there are some devices with Samsung and OnePlus that support Nano. So all the other devices, they are all going to fail, and they are just going to go into unavailable status and throw some error. So once you have the status and once you download the model, you can start using the app as required. So I have a small demo here, which is Book Companion. All it does is, in an offline mode, I type in the title of a book, and it'll just summarize the book for me. And this is all completely offline. Let's see how it works. All right. So first, what I'm trying to do is that I'll make sure that there's no network on this device. So I have disconnected my Wi-Fi. There's no mobile data as well. There was no SIM on this device. All right. So I type in a title of a book. Here, I didn't want to specify which exact book, so I just said book 6 of Harry Potter, and it was smart enough to identify the book. It gave me all the information. It also mentioned what the title is, and all of this without any internet connection. I had given it a request to tell me how the confidence level, how much you know, and do not try to guess things. So if you actually know the response, just give me high confidence, and if you don't know it, say low confidence or maybe medium confidence if you're not entirely sure. So this is how the summary comes out to be. Now let's see some other examples. All right, so I just entered The Train. I didn't know if there was a novel called The Train. And it somehow picked up something and said that there is a novel called The Train by William Gibson. Okay. I looked it up. There is no such novel. And but maybe there was something related to a train on one of his books, and that's why he probably tried to associate that with this. But the thing is, it did not lie. It told us that it is a medium confident information that he had, and we can trust that, right? It is all right, not a big deal. If he's telling that he doesn't know the information, he's not lying that he has high confidence on it, which is good enough for me.
Was the prompt is it custom prompt?
What do you mean custom prompt?
Yeah, the book title and the author. So you send a custom prompt?
Yeah, I wrote it myself, The Train. Yeah.
No, but
I'll come to the prompt in the app itself, right? Yeah, I'll come to that. Yeah. All right, and then after that, I just entered some gibberish. Let's see what it does with that. All right, so I thought it will come up with some children books or something, but it clearly doesn't have any information about that. So it told us low confidence. It's not giving us any fake information about it, right? All right, so again, there was no internet connection on this one. Every response that we saw, it was a JSON response, right? You could see that the response was streaming. It was getting generated as a JSON, and then showing us the actual response. It made sure that it had it used the indicators exactly how I expected it to use, and also the responses were pretty quick, right? Because there was no network latency at all in it. All right. Coming to the prompt part, right? Because I wanted to use the prompt API, I have created this string. Okay. On the left hand side, you see the actual request prompt. What I've done is, actually the prompt is much larger. For the purpose of slide, I've shortened it. What I've told it is, create a JSON from this response that gives me this much information, and also stick to JSON and all the other details, right? Okay, I have to figure out the novel's details and all of that, right? This was the actual prompt that was sent in the app. This is set in the app, so every request is going to go through the same prompt. On the right hand side, you'll see the APIs that are being used with the prompt. Okay, the prompt is my request. So if you see the generate content request, generate content request, is it visible? Yeah. Yeah, if you see the generate content request, that is the request API call provided by MLKit. All you have to do is set your text in there. If you're also using multimodal, you can set your images as well along with it. Not images, just one image along with it. And then you can wait for, you can check the response. I have set some parameters also along with it. I'll come to that in the next slide. And after that is being sent, I start receiving the stream of information. I start getting the response. And the response is then appended and created like a general response. I've just created a single normal text out of it. All right. Fine. So after this, you might wonder, why did I specifically made sure that it responds with a JSON, right? He could have just given us some free-form information, just given us enough information to solve this, right? Why do we specifically need a JSON? Why do we need a structured response from it? Now, if we don't give a structured response for it, it will start getting creative. The more it gets creative, the harder it gets for us to parse that data, right? So that is why I explicitly made sure that I mentioned JSON only, I think 3 or 4 times in one prompt. Yeah. And along with that, I also passed in a temperature field with it. If you see, there's this 0.22F applied, which tells it to be very deterministic. I want a deterministic JSON is what I am asking it for, in short. Again, don't be creative at all. Just stick to the JSON. And then I also applied a max output token as 256, which is also a capped response. Now, these parameters are actually optional, but these are very important parameters if you want to make use of Nano. That is because the highest number of tokens that it can respond to us is 256. So which means that if you send in any information, then Nano is going to respond to you within 256 tokens. Any information beyond that, it keeps failing. Okay, I have tried it. I have tried to exceed the parameter token here to maybe something else, and then it will just crash probably because it cannot do beyond 256. So I think that is the reason why summarization is one of its powerful tools, because when you can send in a lot of information, it will just return you the desired expected number of tokens. All right, again, coming back to the free-form response, like I said, we want it to be a JSON because we should be able to parse it. But one of the biggest advantages is asking it to stay in its boundaries is to make sure that it does not end up using a lot of tokens. Because the more tokens it uses, the more difficult it gets for us to understand the response, right? So just to stay in the limitations, we expect it to send us a JSON response. All right. So this was the response that we got. All right. Fine. Now, after this, I would just like to mention, like I said, it has a lot of its advantages, but it also has its own problems, right? It is one of the biggest challenges is that it only gives us a response on 256 tokens that like I mentioned earlier, but it lets you send in a lot of tokens. So the input can be pretty large. It can be about 4,000 tokens, which is approximately 3,000 words, English words. Like I said, it helps you in sending a lot of heavy data. Like for example, it can let you add like for summarization, if you have like a huge lengthy text, you can add it. Or maybe if you have images to add, you can add it and then expect it to give you a summary from an image. So I think it is good enough, right? The other problem with Nano, apart from the device fragmentation that I had mentioned earlier, that it is available only on certain devices. Right now, it is available on certain devices, but going forward, probably it will become more and more easier to have it. Of course, it cannot have any backward compatibility because the earlier devices did not have the chips, which is required to execute Nano. Also, it is available on only flagship devices. If you remember, I mentioned only Pixel, Samsung, and I think OnePlus. Anything beyond that, none of those have Nano yet on the devices. But also, it does not support it is not supported on any rooted devices. So let's say you're already using a device which has Nano, and then later on root that device. The device will not support Nano anymore. It will not help you out because it is very high on security. The whole idea behind Nano is privacy, right? If you root a device, there is a chance that the sensitive information might get leaked, and that is why it does not support rooted devices. Again, like I mentioned earlier, all the requests are secure, but they are also isolated. By isolated, I mean they are isolated from the other apps, but they are also isolated in a way that all the new requests that come have no memory of the earlier requests. So these are like single requests being sent and response received. Next time you do any of those operations again, it will have no memory of it. So all requests and responses are isolated completely from each other. Okay, all right. So the one last problem that Nano has, apart from all of this, is its inference quota. So every app has a limitation on how much Nano they can use, okay? Because there's just one AI core, there's just one Nano, and there could be multiple apps using it, right? So there is a limitation on how they access it. And that is pretty valid, right? Your app cannot, because they also want to make sure that we use the battery properly, optimized battery usage, your app cannot be firing multiple requests to Nano in one go. So you cannot have like let's say, a for loop that keeps requesting things to Nano. It'll just give up. It'll say, I'm too busy. The error code is busy if you send it too many requests at one time. There's also, I think, a per day limit. So if you use up a lot of battery, it is going to just tell you that this is all I can give you today. So there is a per day limit and also a limit for sorry. Yeah, I think I've covered all of it now. All right. So any questions? Thank you so much.